Glasgow Caledonian University is currently working with Historic Scotland at a location in East Ayrshire. Thermal monitoring equipment has been installed in an outbuilding which has been empty and unused for many years. This has provided a rare and valuable opportunity to test various insulation solutions, starting from a completely uninsulated state. The front elevation of the building is completely unshielded to the north and overlooks a large area. A solar panel is installed on the rear of the building, on the south-facing aspect. After mounting the bracket, the drill bit shows wet residue from previous repointing using mortar, which has caused dampness to become trapped in the wall. The solar panel is angled for maximum sunlight, and the power cable is fed through a gap in the window. There is no mains power on site, so battery and solar panel are used to power the 4 data loggers.
Okay, I'm just about to install one of the heat flow meters onto the original wall surface here. The plaster board had been damaged, so it would make no sense in taking a measurement on the plasterboard, because when the room is heated, you'll get warm air passing up behind the plasterboard and it will give you a false reading. So we might as well take advantage of the exposed original wall surface and take a direct reading through the old construction. So because the surface is quite uneven, I'm just going to apply some silicon sealant.
The silicon sealant is applied to ensure a smooth surface for conduction.
Hopefully, I've put another heat flux meter on the same wall, but here the plasterboard is in better condition, so we can measure the effect of the plasterboard on how that affects the heat loss through the wall, and then we'll have a comparison with the heat loss directly through the stone.
The heat flux meters and thermocouples are connected to the data loggers. There are 4 data loggers in total, 1 for each room in the house.
We've now finished the installation of the heat flux meters on the walls. So we've put in 4 per room, and we've tried to cover the different wall types. So, for example, up here the walls appear to be lath and plaster, whereas downstairs they're more or less I think all plasterboard. And so now we've finished that installation, we're going to start adding temperature sensors to the surface of each of the heat flow meters. So we're just applying some double-sided tape to the heat flux meter and sticking the sensor on, and then covering that with a bit of masking tape to hold it firm. So that's the installation complete. This is the external temperature sensor with its own logger, and it's mounted inside a shield which prevents solar radiation hitting the sensor, so that you get a correct measurement of the actual outdoor temperature, which we use as the reference temperature.
The Tiny Tag module stores data from the air temperature sensor to be downloaded later for analysis. Further instruments for measurement of the local climate will also be installed.
I've got another external temperature sensor here that's spare, which I'm just going to mount behind the photovoltaic panel, just so we've got a bit of extra information. I'm just going to configure some small temperature and humidity sensors that I'm going to place around the building. So they'll give us, particularly with the humidity, it'd be interesting because this building has been left for 6 years unoccupied, so particularly as we get some heating on, it'd be interesting to see what happens with the humidity levels.
A laptop is then used to configure the various data logging equipment. Once configured, the data loggers remember their settings and begin to collect data from the various sensors. The laptop can therefore be taken off-site and is not required for the constant operation of the data loggers. The Rich Centre at Glasgow Caledonian University is carrying out a programme of work for English Heritage and Historic Scotland to investigate methods of improving the thermal performance of traditional walls and windows without compromising the appearance of the building. This work will continue over the next winter to enable the owners of historic buildings to make appropriate decisions as to ways of improving the energy efficiency and sustainability of their stock.